a tiny stone that you can pick up from your neighborhood, everyday objects. Okay, we will be using this mainly for one experiment, which is called the simple pendulum experiment, where instead of having a ready-made setup at the lab, you will be making your own experiment. Students who have done this before have been very excited by it. They later on told us it is their most exciting experiment out of the 5. Okay, what are we going to do? So before the lab, not today, but for the future labs, before the lab, we will be uploading the assigned experiment, the manual, and some sort of introductory video. Sometimes it will be there, sometimes it won't, the introductory video. Go through it, read it, so that when you come to the lab, you know an idea what's going on. During the lab session, an instructor will always be available, either myself or someone else will be available here on Moodle, on Google Meet. We will explain the experiment briefly, but not in detail. So the details are all in the lab manual. One of the skills you learn in this course is to read a manual and know how to follow it. The rest of the lab time will be used by you to perform the experiment, analysis, and submit the lab report. I'll show you how to do that in a minute. Okay. The answer sheet is a Word file. You can print it, or you can just simply type directly into it, which is easier for you. Students are divided into 10 different groups, each with a different data set. I will show you where to find your name in a minute, so you know which data group to use. Now, these are the experiments we will be doing. Today, we're going to be looking at graph plotting and significant figures. In a couple of weeks' time, we'll be looking at measurements of length and density. Week 8, we'll look at free fall. Week 9, we'll look at Hooke's law. Actually, there's something wrong in this. Week 7, we'll be looking at free fall. This is wrong. Week 9, we'll be looking at Hooke's law. And week 11, we will be looking at the simple pendulum. This is all, of course, available in your work plan on Moodle. So I'll go to Moodle now, and I'll show you. No, labs are not recorded, Sarah. Lectures are recorded, labs are not recorded, because the submissions and the work are all done live. Okay, so once the lab is done, we will be we will give you a grace period, so you know it's not the exact 3 hours, but everything will be done within a few hours time. So there is no point in recording the lab sessions. Also, it makes it, because we'll be here and labs and tutorials have a lot of discussion going on through them. Okay, so we will be doing a lot of discussions. I want you to ask questions when you're stuck. And I have found that most students, if there is recording, it doesn't work. Okay, so this is what you see. Well, some of this might not be visible to you, but generally speaking, this is what you see in on your Moodle. Now, there's an instructional video for lab that was uploaded a couple of days ago here. Okay, if you want to look at it. But more importantly, on the lab week, you will see this here. Now, you will see I have 4 copies of this, one for each section. You will only see one version, whichever is applicable to your section. So you will only be able to see Lab 1 graph plotting section 21. You will not see the rest. So we have this graph plotting folder. You have a bunch of data sets. You have students with group numbers. You have an answer sheet template. You have a graph plotting video. You have a manual for that experiment. And you have your student lab instructions. Okay. Okay. What's the difference in all of these? Now, I have already downloaded these beforehand so that I don't download one at a time. This is what your lab manual looks like. Okay, it goes through an introduction of the experiment. Today's experiment is a bit different in that I will be doing a lot of explaining, well, a bit of explaining in the beginning. This is where the experiment starts, lab session 1. It explains to you what you do. There's a bit of graphing. There's a video. There's an appendix explaining to you how to draw a graph. I will also show you how to do it. And then you have, well, this is all unique to the first lab where you have samples of everything. And it shows you everything you need to do. Another thing you have is your answer sheet template. So you will get a blank version of this. This is empty. You have to copy the data that belongs to your group, which I will show you in a little bit. It tells you exactly what to do, how many marks for each bit, etc., etc. You fill this in. The easiest version is not to even print it, just type it in. Some calculations. You can do it over a paper and print it, do it over a paper, or you can do it over a paper, take a photo and attach the photo here. You plot a graph. We'll go over graph plotting in a second. And you write your results here. And then you submit it. I'll show you how submission is done in a little bit. For section 21, if you click, you will find your name, your student ID, your name, and some sort of group number that is written next to you. Okay, so for example, this person with this ID is part of group number 1. And when they go to the data sets part, they will choose group 1 data table. And this is their table with the data. Okay. Please make sure you choose the data from your correct group. Otherwise, we will end up with a lot of headache. Okay. What else? Yes, submission. Now, once you finish this, you save it on your Moodle. Same place, week 2, you will find this thing, Lab 1 Graph Plotting, section 21. You click on it. I'll change my role to student so you see exactly what you will see. What? Oh, I'm not part of the correct group. Sorry about that. Okay, so what you do is you have a button here at the bottom that says Add Submission. You click on Add Submission, and you simply drag and drop, or you choose the file. I will choose the drag and drop. I'll simply drag and drop this file here, and that's it. And then I will click on Save Changes. Once I have saved my changes, it will ask me to. Now this is a pain because I'm not a student. But once I submit it, there will be a button here. See, draft, not submitted yet. You can remove it, you can edit it, because you can still make changes to your submission. Once you click on Submit Assignment, that's it. It sends the file back to your instructor. If it's me, then it's me. If it's someone else, then it's someone else. And then that's it. We will mark it. We will send it back to you also via Moodle electronically. And you will be able to see your mark, your feedback on each section by section basis. What else? Graph plotting. Okay. I will stop sharing. And now I will ask, do you have any questions on how labs are going to be run in the first place?
Doctor,
Aywa?
how to connect with other group, with the member of the group?
you're not working in groups because كل واحد فيكم في بيت. That's very difficult to work in groups. Each person will be doing it on their own and submitting it on their own. The groups are just, to know which data you use.
Okay.
Okay. Sarah, can we submit it as pictures? Yes, you can. You can submit photos, you can submit Excel documents, Word documents, and PowerPoints. Okay, but the easiest way for it is through the Word document. You just simply type it in. So you don't even need to take any photos. You don't need to print. You don't need to scan. You don't need to take photos. Simply that Word document, you type on it, you send it back. It's the easiest way to do it for you. Any other questions? Okay, if you say so.
Doctor, work alone or group?
Alone. Each person work on their own. It's impossible to work in groups since each one of you is in a separate home.
Okay.
Doctor,
Yeah.
you will explain how can we did we do the first lab?
Yes, I will start now. So once we finish, basically this was how the lab is run. I will start the actual lab in about 2 minutes time. If you once we're done with the question and answer.
Okay, thank you.
So, Doctor,
Yeah.
we see our group from the student list section,
Mm-hmm.
and then choose the group that we have. You have already given to us.
Yes, for the data.
For the data, yeah. And
Yes.
answer it and then upload it to you.
Perfect. Well, you upload it to Moodle.
Like that.
And then whichever instructor is, because it will, for this section, for example, 1 week will be me, 1 week will be Fatin. We will be alternating. So whomever is responsible will be seeing it and marking it.
Okay, thank you.
When is the deadline? Okay, so labs start at 2:15. Okay, and technically speaking, they end at 5 o'clock. في نسبة مرونة وتسامح, we will be leaving it up until 6 o'clock most times. Okay, the 4 hours or the 3 hours are more than enough to do the work. Okay, usually during labs, during class, students finish it in under 2 hours. Actually, for the last 3 semesters, we have been running it with 2-hour labs instead of 3-hour labs. So that's one. But you will have more than enough time to submit. What we will not be doing is we will not be cutting you off after the deadline. You will still be able to submit, but it will appear to us as a late submission. Okay, late submissions usually have penalties associated with it, but you have about 4 hours to submit, which is more than enough. If you just sit down and do it properly, I assure you and I guarantee you it can be done in about 30 minutes. Okay. Perfect. Okay, so let's start with the actual lab. If there are no more questions, we are actually lucky because you are also my section. So I both lecture and and teach this tutorial/lab group, which means I can go back and forth between the two. So if you remember in the lecture, we mentioned something called significant figures. And we said we will be looking at this further in the lab. and this is what we're going to be doing today. What we do now, I was late. When were you late? Okay, I'll just continue. So let me share my screen again and explain the idea of significant figures. Present. Entire screen. This, that, this. Okay, we mentioned two words in our lecture: precision and accuracy. And what we said was these two words are not the same thing. Okay, we said they have very different meanings, although we use them regularly in a very interchangeable fashion. Now I'm going to write 4 different numbers on the board, and I want you to think if there is a difference, any difference between those 2 numbers. Okay, I didn't write 3, I wrote 6 numbers, sorry. But do you think there is any difference between 1, sorry, not this, if there's any difference between 1, 2, or 3?
Yes.
Yes.
Okay, good. So I'm going to open the chat screen on my phone, so that if you have an issue, you type, I can see it while I am also in full screen mode. Where's Google Meet? As you can see, we're all learning together how to make this work. Chat. Okay. If you send something by chat now, I'll be able to see it in real time. Look, I'm trying to figure it out on my end. Sorry, just give me a second. Because I cannot see the writing and display my whiteboard at the same time, so I have to print it. Okay, that's much better. Okay. Remember we said precision and accuracy. Okay. Now, one of them has to do with what we call significant figures. Why? When I say you have learned early on in your life something called rounding, yeah? when I say, for example, 5.5, it can really be anywhere between 5.54999. If I round this will still be 5.5. Or it can be anywhere, okay? So when I write 5.5, what I mean is really it can be anywhere between these two numbers, because if I actually this, yeah, if I round either of these numbers, it will either be if I round 5.45, it will be 5.5. If I round 5.54, it will also be rounded to 5.5. So inherently, when I give you the reading 5.5, there's a certain degree of precision in that number. Now, when I tell you 5.50, this has a very different meaning to 5.5, because 5.50 cannot be any of these. We have tightened the boundaries further. So 5.50, if I try to do the rounding, it can only really be from 5.504 up to 5.50, no. These are my boundaries now. Okay, so my number is much more precise. Okay, now what happens is when we write our results, for example, in experiments or in different things, okay, the amount of information we convey depends on the number of significant figures we use. If I write 10, it's very different than if I write 10.0. It's very different than if I write 10.00. So first thing first, we're going to define something called a significant figure, which roughly translates to something that matters, a number that matters. From a really, really long time, when we ever wanted to really diss someone, كنا نقول له أنت صفر على الشمال, because a 0 on the left doesn't count. We know that much. Yes? So we define what we call is a significant figure to be a number that actually makes a difference. Okay, what do I mean by this? This number 153 has 3 significant figures. 1, 2, 3. This number has 4 significant figures. Okay, so any number that is non-zero is significant. What about zeros? Now, zeros have different rules. This number still has only 1 significant figure, because it doesn't matter how many zeros I put on the left, it still says 1. This number has 4 zeros, 1 before the decimal point and 3 after the decimal point, but it still only has 2 significant figures. So you only start counting once you get to a number that is not 0. You start from the left, and you keep going until you get to a number that is non-zero. Yes?
Not 2.
Sorry, say that again? I didn't hear you.
It is 5. It's 5 significant. Not 2.
This has 5 decimal points, but 2 significant figures. Can you type? Your voice is actually cutting off, so I cannot hear you properly. Ahmed, your voice is not very clear. It's cutting off. Can you type what you're saying? It is only 2. Leading zeros do not count. Now, I was confused by this myself at some point, but apparently these are the rules. Okay? But zeros after significant figures do count. So if I write 0.03200, then this is 1, 2, 3, 4. So this is 4 significant figures. Why do I say this? Because this tells me how accurate my reading is. Okay. Now, I myself, sometimes I get very confused by this. So the general rule I try to remember is 0 on the left, if there is no other number, doesn't count. Now, the last rule is zeros after a significant figure only count if we have a decimal point. So this is still 1 SF. This is 2 SF. Why? Because this number, the first one on the top, I still don't know the accuracy to more than 1 significant figures. Okay. Think of a weighing scale. Okay. If I say just 10 without a decimal point, okay, the best I can know is this is 10 plus or minus 4. It will still round off to 10. But if I say 10 point, it means that it could have been 14 or 15 or 16, and I would have been able to measure that accurately. The first number doesn't tell me that. So how do we operate with significant figures? There are 2 rules. One rule is for addition and subtraction. The other rule is for multiplication and division. For addition and subtraction, we look at significant figures, but also decimal points. And the rule is least DP wins. So if I am doing 34.22 plus 31.263469, I can only report my final result to 2 decimal places because that is the least accurate thing that I have. the least precise measurement. So in my calculator, I'm going to put 34.22 plus 31.2634679, and I will get 65.48344679. But what I actually present when I write my answer is, excellent, Nahla, 65.48. I don't write the rest. It's the same if I subtract. What if I have 3 plus 5.6? What should my answer be?
1 decimal place.
How many decimal places do we have in 3?
1.
1.
Just in 3, we do have 1. So here we have 1 decimal place. This is not 0.3, this is just 3. So we have 0 decimal places. It's just a whole number, right? So this one is 0 decimal places. This one is 1 decimal place, which means that the least number, 0, wins. So in a calculator, this will give me 8.6. But the best I can say about it in reality is simply 9 to 0. Okay. Now this is very counterintuitive, even after so many years that I am working in physics. This is very, very confusing to me because this is obvious. It's 8.6. Why do I have to write 9? It makes no physical sense to me. And turns out, although it might sound very, very stupid for these very small numbers or very simple examples, it actually ends up being really important when you're doing larger calculations later on. Because really, especially in experiments, دائما نسمع بالعربي شيء نسميه الحلقة الأضعف في السلسلة تحدد مسير المجموعة. Well, this is what happens. Your least accurate piece of equipment, your least precise piece of equipment that gives you the least number of decimal places or significant figures is the one that limits how much you can report your data. Okay, so it doesn't matter if all the fancy equipment I have in the lab have, give me data to 5 decimal places. If one piece of equipment gives me just 0 decimal places and that reading goes into the calculation of addition and subtraction, it will still be just in terms of a whole number, which sucks, but it is how it is. Now, what happens in multiplication and division? So this is addition and subtraction. What happens for multiplication and division? We do the same thing, but we actually don't look at decimal points. We look at
significant figures.
Perfect. So here it's the other way around. We look at significant figures. We do our calculation, and again, least significant figure wins. So if I do 3.12 times 1.1, my calculator will give me 3.432. So my calculator will actually give me this. But the best I can actually say is, since this is 3 significant figures and this is 2 significant figures, this is my first, this is my second, the best I can say is 3.4 to 2 significant figures. Now here's a question. What if I have a really long calculation, not just one operation, a whole series of multiple operations? Then what do we do? Well, what we do is we do, and this is very, very important. I went silent there for a second to make sure that all of you are listening. This is very, very important, and I am actually going to write it in block letters, and please do copy this wherever you copy it into your brain. Do not round anything can you mute your mic, please? Someone's mic is not muted. Ahmed Al-Hinai, can you please mute your mic? Thank you. Do not round anything except in two cases. One, reporting result. Two, final answer. And this is very, very, very extremely important. Okay, so let me give you a physical example. The question is, and we will use a very simple example. The question is A plus B, C divided by C minus D. What is it? Well, A, B, C, D. 4 significant figures, 3 decimal places. 2 decimal places, 2 significant figures. Seven decimal places, 4 significant figures. 6 decimal places, 3 significant figures. Now, it really depends how your question is written. And I'm going to write the questions, okay, very, very clearly. A, what is A plus B? B, what is C minus D? And C, what is A plus B divided by C minus D? Now, these 3 questions are answered very, very differently. What is A plus B? I do 3.125 plus 0.35. This is 3.475. To what should I round it off?
2 decimal places.
Perfect. 3.48 to 2 decimal places. And C minus D, okay, will be 0.000177, which rounded off, this has 7 and this has 6 decimal places. So to 6 decimal places, this will be 0.1, 2, 3, 4, 5, 6 decimal places. This will be the answer. I rounded them off. But when I come to this question, what is the final thing? I do not, and I can't say this enough, I do not use these. Okay, I do not use these numbers. I use the full numbers for the calculation. So I do 3.475 divided by 0.00000177 which will give me 196.327.6836. Okay. And now what I do is, upstairs I have 4 significant figures. Downstairs I have 3 significant figures. So I use 3 significant figures, and this is 196,000. Notice I don't put a dot at the end, otherwise this would make it 6 significant figures, not 3. But on the other hand, and I am going to do multiple X's so that you remember this is wrong, if I had used the rounded figures of 3.48 divided by 0.000018, what would I have gotten? My answer would have been 193,000, which is 3,000 off the correct value. Okay. I cannot tell you I cannot stress how important this is, because I have seen so many students over the years make this mistake. They round off A, they round off B, and then they end up using the rounded off values for C, ending up with a result that is wildly different than the correct result. So please, 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 please do not do that. Okay? Only round off in the very final answer when you are actually writing down the answer. So here we wrote down the answer, that's why we rounded. Here we wrote down the answer, that's why we rounded. Here when we wrote down the final answer, we rounded. In between, we do not round.
Okay.
Okay.
Doctor, you
Aywa.
start in the lab or because have
So
2
now we're
hours
going
just
to, yes. No, you'll have more. You'll have more. You will not only have 2 hours. So I'll leave it open for submission. I'll tell you that in a second. Okay. So this is actually still part of the lab. If you open your lab manual, you will see this is the first 3 pages of your lab manual. Okay, I'll stop
Doctor,
sharing. Yes.
I have problem with decimal points. Can you explain it again?
So decimal points
Only.
is how many numbers you have after the dot.
Okay. Only after the dot?
Only after the dot. So you start counting after the dot.
Okay.
So if I have 0.1234, that would be 4 decimal points. How do we know if the number is an exact number? What do you mean by exact number? Like a full number? One to 9. Well, it can be more than 9. It can be any number. If there is a dot after it. So if I simply write 12 like this, okay, I do not assume this is an exact 12. I assume it is anywhere between 11.5 to 12.4. But if I write 12 dot, then this is exactly 12.0. Because what this tells me is this dot tells me that I am accurate, I am precise enough to be able to write 12.1, 12.2, 12 point blah. Okay, so the fact that I wrote only 12 point, I mean 12, exact number. When we consider the significant figure is infinity. Okay, not quite. We don't have something called infinite significant figures. Okay, you have to you have to count them. Even infinity, there is countable and incountable infinity. Okay, so at least in this course, you will not have to deal with infinite significant figures. What you can write, however, is you can use the scientific notation. How many here are how many here are used with the idea of scientific notation, being able to write in scientific notation? Okay, so it seems that quite a few of you are used with the idea of scientific notation. Give me a second. I want to see what your book says about it. Okay, so your book has a suggestion to know the exact numbers. Their suggestion is use scientific notation. So in this example, if I want to avoid the ambiguity between 12 exact and 12 non-exact, I can write 1.2 times 10 to the power 1 to mean this 12, or actually this is a bad example. Let me give you a better example because this has exceptions. Let me delete this. Say I want the number 3,500. Now I don't know, is it 3,500 to two significant figures or 3 or 4? So to one significant figure, to two significant figures, I will do this. Okay. Otherwise, I can do this or this. So here, this is very, very clear. This is to 2SF because I've written 3.5. This is to 3 significant figures because I wrote 3.50. And here, it's 4 significant figures because I wrote 3.500. Okay, but still this is not infinity significant figures. It's 2, 3, and 4. Okay. All right, so this was the introduction to our lab, and we do it in the lab because the lab is all about experimentation, and it is important when you report your experimental results that you follow these conventions. So for example, if you are measuring the length of something with a ruler, okay, you might write to me it is 12.0 centimeters. You might write to me this is 12 centimeters. What would be really, really crazy let me do this. 12.1, 12 centimeters, okay. What would be unacceptable is for you to do some calculation, addition, subtraction, multiplication, division, and then tell me my result is this. Because this does not make any sense, because my ruler cannot give me more than 1 millimeter. My ruler cannot give me more than 1 millimeter accurate precision. So these numbers make no sense. They should not be there. Okay. So you can start now looking through your lab manuals. We have covered the first three pages. You can start from page number 4. Read your manual, see what you want to do. There is a bit about graph plotting and how do we do the graph plotting and how do we analyze the data on the graph. Okay. Actually, you know what? Let me explain that and then you can do the whole lab without me interrupting you whatsoever. 1 second. Okay. How many of you have done graph plotting before in any way whatsoever? In a normal graph, what you will have is you will have an x-axis and a y-axis and some line that what we call a trend line that describes this. Now, what do these mean? Okay, I'll explain them one by one. X is what we call
Time.
Okay, it can be time, but it's not always time. So X is what we call the independent variable. بكتبها بالعربي حر. Okay, Y is what we call a dependent variable, and I'm going to write it in Arabic, مقيد. Okay, what you put on the, this is a question that we always hear from students, ايش احط في الX, ايش احط في الY. You have usually two variables. Which one is the variable that you control? Which one is the variable which you do not control? Okay, so for example, if I have a graph, and I'm going to start becoming very violent now, if I have a graph of, I have two variables, how hard I punch you in the nose and how hard you scream ouch. Okay, أنا أتعمد إني ما أجيب أي أمثلة مال فيزياء هنا. Okay, say for example I have two variables. One is punch strength, and one is ouch volume. Which one goes on the X? Which one goes on the Y? The punch strength goes on the X because this is what I, yes, good, imtinan, excellent. The punch goes on the X because, well, this is what I control. The screaming volume goes on the y-axis because it depends on how hard I punch you. It's not the other way around. Okay, so good. You got this one correctly. Now another example. Say you have time to reach and car speed. Which one is X? Which one is Y?
Time it is X and speed it is Y.
Okay. Anyone else thinks the other way around? Does when you arrive, Okay, time x, time x, time x. One person said car speed is x, speed y, car x. Okay. Okay, we have a lot of opinion. This is good. Okay. Think again, the same as the punch and the ouch. Okay. Which one depends on which one? هل سرعة السيارة تعتمد على نحن ساعة كم نوصل ولا ساعة كم نحن نوصل يعتمد على سرعة السيارة؟ If you think about it for a minute, you will see that نحن نوصل ساعة كم هي اللي تعتمد على سرعة السيارة وليس العكس. صحيح؟ You don't decide your speed later. You decide your speed when you are driving. وقت الوصول يعتمد على سرعة السيارة. بالتالي your car speed actually goes on the X and your time goes on Y. أنا كتبتهم متعمد بهذا معكوسين to get you to remember time doesn't always have to be on X, because the independent variable, the one that we are controlling, is our car speed. Time to reach is something we don't control. It only depends on our speed. Okay. Now, the third thing that you have obviously done at some point before, but a reminder, is what we call the gradient. Otherwise known, some students call it the slope. And I have learned this from my school days. Slope is equal to rise over run, otherwise known as delta y over delta x. Okay, now you will notice two things. You will notice first that when I drew these data points, I did not join them by a line. And this is very, very important. This is very, very different to this. Okay, most students don't realize this. This, the top one, means that I know exactly what is happening between the data points. So if we're taking our example of punch strength versus ouch volume, this tells me that if I know with absolute certainty, if I punch you with here, this is going to be your screen volume. But this does not be true. This might not be true, okay? This is more accurate. The second one is more accurate, what we call a data sample. Okay, so there's a difference between these two, these two types of graph, and that what I am saying here, okay, look, I know at this point this is my value. I know at this point this is my value. I know at this point this is my value. I do not know in between them what are my values. It can be whatever. Okay, and this is what we have in experiments. We don't have this in experiments. We have this in experiments. Okay, so what we do is we have we take a bunch of data, we draw it, and usually just by looking at it, it looks like a certain shape. Okay, now in this course, most of them will be some form of straight line. They don't have to always be straight line, but this looks like a straight line to me, with the exception of one point, which is a little bit weird. I will try to find a line. First, what I do is I take the average point. What is the average of my x's and the average of my y's? And my average will probably be somewhere here. I put the ruler here. I look what is the best looking line possible through all of these. Yeah. This looks like a good enough line to me, and I will draw this line like this. Okay. Now, the gradient of this line or the slope of this line tells me what is the relationship between the dependent and independent variables. So, for example, it might tell me that for each doubling of my punch strength, you will shout 10 times louder, maybe. Okay. Or maybe it will tell me that if I double my speed, I will half my arrival time, or maybe not, depending on the road. Okay, this is what we call a slope. Now, many students end up doing what? They just end up calculating. They don't know what the slope means. It's very important to know what is the slope. What does it mean? Why are we even calculating the slope? Don't just calculate it because the manual tells you to calculate it. You need to know why are you calculating the slope. Now, what happens is, one of the things we're doing in this course differently this semester is we will be doing this, looking at this through Excel. So I will show you, and there's actually a video on Moodle on how to do this, but I will show you anyway. I will write here X, Y, or, punch, ouch. So you will always remember them. Now, always units. What am I measuring my punch in? Newtons, kilonewtons? Let's say newtons. Okay, your graph needs to always have units. This means nothing unless I know, okay, say for example, I say speed, car speed, time. This means nothing. Unless I say, okay, you know what? This is in kilometers per hour, and this is in hours. Because this will have, this graph will mean very, very different things. If this is not in hours, if this is in seconds, it will mean a very, very different thing. Okay, so headings, punch, ouch. Now we put in some data. I will punch you with increasing force from 100, 150, 275, 300, 422, and 678. I'm not even using nice numbers. And your scream will go, well, scream is not a really good quantifiable thing. But what I'm going to do is I'm going to quantify it in, in decibels. Do you know what decibels are? Decibels are the unit of measuring how loud something is. And I'm going to write something like 20, 30, 40, 60, 60, 60. And I'll tell you why in a second, okay? Decibels is how loud you are. It's the unit of loudness, okay? And it's sometimes logarithmic. Now, how do I plot this? I will choose everything, including the titles, and this has to be in the order X, Y. If this is YX, you get something very, very different, and I'll show you that. Okay. I'll make a mistake here on purpose, and I'll show you in a bit how it looks. So I choose everything, not the XY, because that's just me to show you the title and this. I go insert, and then I choose. Now this looks different in everyone's computer. Okay, so you will have to play around a little bit with your computer until you find how to do it. Here, for example, I see in Excel it's called a scatter chart. And look, I choose the first one where it's only dots, not dots with joining. Okay, see how this looks? And see how this looks? This is only dots. This is dots with lines. Dots with lines look nicer, but it's not correct for experimental data. Okay, so I'll choose this. Okay, now what happens if I mistakenly put Y versus X? Excel always thinks you say X versus Y, even if you give it the wrong data. So see what you get? You get a very, very weird result where you have 1 point in X with 3 different Y's. And you know this is wrong. Okay? So what I do here is, now what I can do is, I can find a trend line. Okay, fit a straight line. There are some things that are important. First, it needs a title. I will write, my title needs to be meaningful. So I write, how loud do I scream when punched? I click on this. I right click and I go on Format Axis. Now, if you have the latest version of Microsoft Excel, okay, this will give you some interesting options. I'll go here, labels. Nope, this is not what I need. See, I also need to find it. This is not it. I need to find somehow to add my labels. To add access labels, legend, and title to the graph, double click on the part you want to edit and change the label. Okay, let me try that. If I double click on this, I will get these. Not useful. Not very useful. Access options. Display units. No. Label position next to access. So I don't know why it's not appearing. And I'm doing this live with you. I haven't prepared this beforehand because I want you to see that even I can have problems with this. Okay, let's see. From add chart inside doctor. Okay. So, there we go. Add chart element. Axes titles. Thank you very much to Malek, Mahmoud, and Amani. Primary horizontal, primary vertical, punch in newtons, and scream volume in decibels. I would also really want a legend on the right. Now, this is not always needed. In this case, we only have one thing, so I don't need a legend. But we have something called a trend line. And trend lines are what we usually do when we try to fit a best line. Okay, so trend line options. I want an automatic line, or I want a solid line. I want it to look nice. I can make it look nice. I can, just choose whatever type line type I want. But then the more important option is here in the data option. Do I want to try to fit it exponentially? This doesn't look like a good exponential fit. Maybe linearly, maybe logarithmically. This one looks good with the logarithmic one, but most things we will be doing in our course are linear. And what we do is, down here, we have display equation on chart. Okay. When I click on this, it shows me this equation. Now I'll make it really, really big so that we can all see it. You are supposed to become much bigger. So I'll just increase the font size. There we go. Okay. And you will see it is in the format of y equals some number x plus some number. We call it the straight line equation. Y equals mx plus c. M is what we call the slope or the gradient, and it shows us the relation between x and y. C is what we call the y-intercept, and what it shows us is usually what happens if we don't have the effect. So in my case, now of course I made these numbers up, so it's not very accurate. In my case, what I would expect it to look like is actually something like this. I would expect it to look something like this, because if I'm doing punch and I'm not punching, so my force is 0, I will expect there to be no screen. So it would make sense to be here. But it's not always here. Sometimes it might intercept here. It might intercept here. It might tell you your car is going in reverse, for example. That's fine. Okay. Any questions? I know I spoke too much. Sorry about that. You can start doing your experiment. I will be here until pretty much 5 o'clock. I'll take a break of about 10 minutes and come back. But I'll be here to answer any questions. إذا الرسم جاب العكس عادي. You mean if I make a mistake of putting X where Y is and Y where X is? No, that usually makes a big problem in interpreting the data. يعني قصدش من اليمين للشمال؟ It's not a big issue. I would really rather have it left to right, but if it's right to left because of the language, then that's fine.
دكتور
أيوة.
وش نحل اللاب مانيوال ولا الستودنت لاب ولا وش اسمه هذاك الثاني بعد؟
Lab manual. So if you go to, let me share my screen one more time.
فهمنا دكتور.
So if you go on Moodle, you go to this folder, graph plotting folder. Oh, fun. Okay, you go to the graph plotting folder and you click on lab manual and you start reading from page 4 onward. Okay, I'll take a 10-minute break. I'll be here. Meanwhile, you start reading the manual. You should understand what you do. It's quite self-explanatory. Okay?
Okay.
Doctor, I have a question.
Yes.
The plotting of the graph, the straight line should be started from the point of the 0 and the axis.
It does not have to start at 0. So say, for example, you are taking measurements of the speed of a car, and your minimum measurement is 60 kilometers an hour. It wouldn't make sense to start at 0, because then you will have a very large portion of your graph that is just, you know, plain with nothing in it. So that would make no sense. So let's see. So the rule is, if this is my page, my graph should take pretty much the entirety of the page as much as possible. Okay, X, Y, title. Okay, and a good graph will be something like this, for example. For example, this would be okay. See, it doesn't start, the Y doesn't start from 0. Okay. Also, this doesn't have to be 0. So for example, this could start from 60 and this could be 100. What would be a problem is if I try to force it to only start from 0. Okay. If you force it to start from 0, you will end up with something like this. This is my page. This is my axis. And if you force it to start from 0 while your data starts from 60, you will end up with something that goes like 0, 10, 20, 30, 40, 50, 60, 70, 80, all the way to 100. And what you will end up with is you will end up with this. But then why is all of this empty? It's a waste of space and you don't get enough detail from it. Yes, Nasira, it's okay to start from negative. You're welcome. موعد التسليم will be 4 hours from now. Okay, so 3:30 all the way until 7:30 you can submit it.
ولا عنده محاضرة بعدين دكتور؟
محاضرة وين؟ ما في محاضرات بعد هذه، هذا اللاب يخلص الساعة 5.
اللي مال ايوه صح، تعلم الساعة 5.
ايوه، فمجال مفتوح لكم، و this is the first lab، ف يعني ما بنحاسب على التأخير كثير هذا المرة.
عادي ننسخ الجداول ونوديهم الوورد ونكتب هناك البيانات؟
ايوه عادي.
اوكي.
ترى اصلا الوورد موجود فيه الجدول. ترى خليني اوريك الوورد. ترى هذا الوورد اللي موجود عندكم، خليني اوريك هذا الوورد اللي موجود عندك. انزين شوف فيه الجدول تايم بوزيشن، وهذا الداتا سيت اللي عندك ايضا بالوورد. يعني انت ممكن كل اللي تسويه هو انك تاخذ هذا كوبي، تروح الوورد مالك وتسويه بيست. تعال انا خربط، خل امسح هذا هو. تمام.
معذرة دكتور،
بيست حال الداتا بعد شيء راجع لك.
دكتور ما حصلت اللي هي الملف الملزومين فيه اللي هو في الموديل.
ثواني خليك معي على الخط. الزهراء هذا اللاب وليست محاضرة، فما راح تكون موجودة على اليوتيوب. المحاضرات موجودة على اليوتيوب وليست اللابات ما موجودة.